Okay, so I've got hold of one of these ESP's 32D microcontroller with built-in Wi-Fi for next to nothing. I think it was £4, and I'm now wondering what I can do with it. I had this crazy idea that maybe we can connect a 7-segment display to it, and using the Wi-Fi ability, can we stream some of the SimConnect data from the flight simulator to this thing to show our altitude on the 7-segment? And I'm wondering, I had an idea that from the software side of things, we can try to use a WebSocket to push the data to this. Obviously, that will help in lowering the latency of the display. Okay, so here's the plan. We've got Microsoft Flight Simulator running on our PC. That by default is emitting data through its SimConnect API. What we're going to do is we're going to write a little bridge software. It's only about 100 lines of code, but it's going to receive the data from SimConnect, and it's going to expose a web server running a WebSocket. So our ESP32 will be the client. It will connect to our bridge, and it will establish a WebSocket, a bidirectional WebSocket between them. And once that's done, all flight telemetry that's picked up can be pushed through the socket, and the ESP will then render that or send that to the 7-segment display. That's the theory. Okay, so these are the things you're going to need for this project. You're going to need, on the hardware side of things, an ESP32 microcontroller board. You're going to need an 8-digit 7-segment display using the MAX 7219 driver, which makes it really easy to program. And we're just going to need 5 wires to connect these two things together. On the software side, we're going to need the Arduino IDE to send the instructions to the ESP32 controller board, and Node.js. This is runtime, which is going to run our little program which streams the data from Microsoft Flight Simulator to our microcontroller. Okay, so in terms of hardware, here's the ESP32D development board. We have an 8-digit 7-segment display, which is the MAX 7219 driver, which makes it very easy to program. And essentially it boils down to 5 wires with our 3-volt live ground, and then we've got a data input, we've got our clock and a chip select. So that's all we need. So those are 18, 19, 21, I believe they are in, and that's all we need to do. Okay, so the first thing we're going to need to do is install some software. So let's start with installing Node.js from nodejs.org. Choose your favorite type of installer. I tend to go for the Windows installer, the MSI. Get that downloaded and installed. That's going to be our runtime for running our little bridge software. If you haven't already got it, download latest Arduino IDE. The time of recording is 238. Go ahead, download that. Finally, the bridge software itself that we're going to run is available from my GitHub account here. It's called SimConnect WS, and you can come to this little green button here and download the zip. Okay, next step, once you've got the zip downloaded for the SimConnect WebSocket, we can extract it all. And inside the folder, you'll see we now have a number of files. So before we can run our little bridge application, there's a variable we need to change within this index.js file. If you right click that, and you can edit it in any kind of text editor, I'm using Notepad here, but you'll see that we need to provide an IP address that this program is going to run on. So the easiest way to find out is if you go back to here, click into this little bar at the top, type in CMD, hit enter, and if you enter IP config, what we're looking for is the IPv4 address. Here I'm on a Wi-Fi, so mine is 192.168.68.123. I can then take that and put it into this hostname field here. Do that, save the file, and close it, and we're ready to run. Okay, let's run the bridge software, see if it works. So let's launch another command prompt. So select the little bar at the top, type CMD. Let's make this bigger. So inside here, these are the files that we've seen. First thing we need to do is install some modules. So we do npm install. Okay, this has downloaded some of the libraries that we use, and now we should be good to go. So to actually run the bridge, we can type node index.js. Okay, and as you can see, it has failed because it's started its server, but then it's tried to connect to SimConnect in Microsoft Flight Simulator, and it's failed. And that's not really surprising because this laptop hasn't got Microsoft Flight Simulator on it. So what do? Well, what we can do is I've added some code to create a mock Flight Simulator stream of data. So we can, if we say set this variable called SimConnect mock, so we'll set SimConnect underscore mock equals 1, and if we try running it again, it will now pretend it's connected to Microsoft Flight Simulator, and it will start generating an altitude for us every second. It's going to just increase by 1, and it'll go on forever. But that's good. That means we've got our bridge software running, and it's pretending to send data as if it's coming from Microsoft Flight Simulator. Okay, so we now have our mock altitude streaming data coming through. It's probably sensible to make sure that the WebSocket side of things is working before we start coding the ESP32. To do that, I've created a little sample client here called client.html. If you edit that in Notepad, you just need to enter the IP that you modified earlier in the index.js. So this is going to basically connect to that bridge and start receiving data from it and update it, a little web page. So if we close that, if I double click client HTML, this is going to establish that WebSocket connection to our bridge, and you can see the data is being pushed through this WebSocket, and it's updating in the same time that our stream is actually updating, as you can see here. So that's good. That means we've established that the bridge is running correctly, the networking side of things is working. In theory, we're good to start looking at getting the ESP configured. Okay, so I now have my ESP32 connected to my laptop, so we can now upload the sketch to it, which is going to connect to that WebSocket server, the bridge, and hopefully display the altitude. Now, within the zip you downloaded earlier, there is a folder called ESP32. Inside there is a sketch folder and a sketch. If we double click it, we have the sketch, which is, I think I got it down to about 73 lines of code. So before we can actually upload this and compile it, it's going to require a couple of libraries. So you'll need to install Arduino WebSockets, which you can find here. You can, again, hit the green button, download the zip, and then back in here you can go to include library and add zip library. Select your zip and you should be good to go. Install this Max 7219 library, which is actually called TM1638 Plus. So if I look at my libraries, TM1638 Plus. If you haven't got this installed, just install that here. So with those two libraries installed, we should be good to go, and we just need to populate some variables. Our Wi-Fi network SSID goes in here, your Wi-Fi password, the bridge IP address that we've been using needs to be updated here, and then the pins need to be set for your 7-segment display. As I mentioned, mine was on 18, 19 and 21. So with the variables all populated, we can now compile and upload the sketch to the ESP32. Click upload and let's let it compile. Now click the serial monitor. We can see that it's connected. Okay, so the moment of truth. We've got our ESP connected. We've got our bridge running in a minute. So let's node index.js. We've now got that working. And what I'm going to do now is I'm going to restart the ESP, and there we go. We have it. We have action. And there's our altitude being updated as it's being updated over here. Fantastic. Okay, so here's our panel. I've got my flight sim running. We've got altitude 250, is it? And I'm going to start my bridge. So I'm going to run. There's the data that's flying through. So now we can restart. So it connects. It should connect to the Wi-Fi, then connect to our bridge. There we go, 236. Bring this down so you can see here. I'm going to change the barometric pressure, and you can see it change in real time, and the latency is pretty damn good. If we now take it all the way down to maybe 100 feet. That is great. That's all Wi-Fi. Increase it. And decrease it. Happy with that.